This is Tejas Viswanathan, and this is my FedEx project for Mrs. DeBrossi's 8th grade math class. I hope you enjoy. In this video, I'm going to go over 7 lessons in Chapter 1. Let's begin Lesson 1. In Lesson 1, we're going to be talking about expressions and variables. Now, before we can do some examples, we have to know what these are, what they mean actually. Variables are a letter that represents one or more numbers. So, let's say B, because that's a letter. So B is the variable it represents. So the expression means a problem. When it says evaluate an expression, that means evaluate the problem. Now, evaluate means substitute the letter for the number. So in this example, solve 3b if b equals 5. So always you must rewrite the problem. Well, that's only if you have it on a separate sheet of paper, but in this case, the first step is to substitute. We know that b equals 5. So we do the substitution, and that's 3 times 5. And you may notice that I haven't put the multiplication symbol. That is because in algebra we don't use it, so that means multiplication. So now we solve the problem. 3 times 5 is 15. Alright, let's do another one. It says solve 6b plus 9c plus 8c if b equals 11 and c equals 13. So we have to do the substitution, which is 6 times 11 plus 9 times 13. So 6 times 11 is 66. And then we gotta add, because we can't forget about the symbol. And 9 times 13 is 117. Now we do the problem. 66 plus 117 is 183. Okay, that's lesson 1. Lesson 2, powers and exponents. Powers and exponents, it's quite easy. Now, a power means repeated multiplication. So if I were to say 10, repeat 10. So in power form, it's 10 times 10 times 10 times 10, etc. So, yeah, that's what power is. Now, there are 2 key words. So let's do this. That is 8 to the 4th. You would read that as 8 to the 4th power. The base would be 8 because that's the number. And now there is a clue. Which one is the exponent? The exponent is this 4 right here. Now when you're asked to rewrite it, we need to make this small enough and make it not too big, because otherwise the teacher may think that it will be 84. So this is the exponent, and that's the power. Not the power, the base. So now let's look at a few examples. It says solve 8 to the 2nd power. Now normally people don't say 8 to the 2nd power. Some people do. But normally you would read this as 8 squared. So what is a power? Now we repeat the multiplication of the base. So 8 squared means 8 times 8. So 8 times 8 is 64. Now it says solve 8 to the 3rd power. And now same thing, same logic applies, but it's not squared, it's 8 cubed. You would read the 3 as a cube. And all the 8 to the 1st power, there's no special word. You just say 8 to the 1st power, 8 to the 4th power, 8 to the 5th power, etc. So solve 8 to the 3rd power. So we know that 8 times 8, that 8 squared is 64. So now 64 times 8. So So that would be 492. Let's do another example. Now, in this problem, this is a little different. It says write the product using exponential form. So what that basically means is write this in an exponent. So it says 10 times 10 times 10. So since there are 3 10s right here, it would be 10 cubed. And then it says 9 times 9. Since there are 2 9s, 9 squared. Now, 3 times 3 times 3 times 3 times 3. There are 5 ones. 1, 2, 3, 4, 5. So that's 3 to the 5th power. That's it. Lesson 3. Orders of operations. Now this is really important because in any math problems you have to use orders of operations. Now an easy way to remember it is PEMDAS. Well, PEMDAS, it's actually an abbreviation. So P stands for parentheses. I may have spelled that wrong. I apologize if I misspelled that wrong. Then E stands for exponents. Then the M stands for multiplication. D stands for division. A stands for addition. And that stands for subtraction. So a little fun way to remember this is please for P, excuse for E, my for M, dear for D, and for A, Sally for S. So please excuse my dear and Sally. So let's start off with an example. It says solve 8 plus 9 minus 3 squared times 9. So remember, you always have to go, when you're solving a problem, left to right. So first, in PEMDAS, we have the parentheses. You have to do it in order. So 8 plus 9, 17, and you have to always rewrite the problem, like I said before. Times minus 3 squared times 9. So then 17 minus 3 squared times 9. So next in PEMDAS is exponents. So 3 squared equals, in our exponents and powers video, we should know how to do an expression. So 3 squared is 9. 17 minus 9. Now, next in PEMDAS is multiplication. Even though I said left to right, you still have to follow PEMDAS. So 9 times 9 is 81. Now, we'll have to go over in integers. So, in this, so 17 minus 81 would be negative 64. Let's do another example. To solve 9 times 3 divided by 3 squared plus 10. First in PEMDAS, parentheses, 9 times 3 is 27, divided by 3 squared plus 10. Next, the exponents in PEMDAS, 27 divided by 9 plus 10. Then, PEMDAS, next is the division, 3 plus 10. Then 3 plus 10 is 13. That's your final answer. That was pretty easy. You should know how to do it. Lesson 4, comparing and ordering integers. Integers mean numbers. So all the numbers we know, obviously, they are called integers. Now there are 2 types of integers. Positive, which is more than 0, and negative, which is less than 0. 0 is neither positive nor negative. You never say negative 0 or positive 0. You just say 0. Because 0 is called neutral, which means it's neither positive nor negative. So, the question says, order the integers from least to greatest. the numbers are -5, 6, -8, 10, -11, 0, and 5. So the least is actually -11. It may seem like the biggest, but it has the negative symbol. So -11 is our least. Then -8. Then next is 0. Then is 5. Oh, sorry about this, guys. I forgot -5. Which goes here. Then 10. Then 6. Actually, I forgot. I messed up here, guys. Sorry about that. So, this says the absolute value of 0. Absolute value means the distance from 0. So since 0 is neither negative nor positive, the absolute value is 0. The absolute value of -5. It's asking for the absolute value, meaning the distance. So that's 5. The absolute value of +5. It's not asking for the opposite, so it's +5. So, the opposite of 0, now we come to the opposite. So obviously there's no negative for 0, it's neutral, so 0. The opposite of -5 is +5, and then the opposite of 5 is -5. Lesson 5, adding and subtracting integers. Let's look at a few examples right here. It says, solve -5 plus 2. Let's do this step by step slowly. So, the signs are different. That means it becomes positive or it goes up. When the signs are the same, it goes down negative. So, -5 plus 2. So, since the signs are different, then it is going up. So, -5 plus 2, you're actually doing -5 plus -2. Now it's good to write it to make you remember, so you don't get confused. So sorry guys, -5 minus -2, and then that equals 3, -3. Sorry. So next example, -10 plus +12. Same rules apply. You're doing -10 minus -12. So, -10 minus -12, or -10 plus 12 is 1. Positive 1, actually. Then, -5 plus -10. So, when the signs are the same, you go down. So, -5 plus -10. So, that would be -15. And 6 plus -6. Think of it as 6 minus 6. And your answer is 0. Let's do another example. That was addition. And now we're going to do subtraction. So, -5 minus -15. You're actually going up, like I said before. Like I showed in the other example up there. So, -5 minus -15 is 10. Now, 10 minus -6. It's like you're doing 10 plus 6. So, 10 plus 6 is 16. Now, next is -15 minus 10. So, think of it as -15 plus -10. So that would be -25. Let's do another subtraction. -5 minus -5. So it's like you're doing -5 plus +5. So that equals 0. Then -10 minus 0 is -10. Lesson 6, and the final lesson. Multiplying and dividing integers. Let's go over So in this tic-tac-toe board, it looks like a tic-tac-board, but this will help you remember. So in multiplication and division, it says positive, negative, and negative. So that means a positive plus times a negative or divided equals a negative. Same thing. Negative times or divided by plus a positive actually equals a negative. Then obviously we know that two positives equals a positive, but a negative times a negative equals a positive because the signs are the same. When the signs are the same, it is a positive. When signs are different, it's negative. So let's do a few examples. So negative 5 times 2. Signs are different. So negative 5 times 2, you can do the arithmetic in your head, which is negative 10. And then 0 times 2 obviously is 0. Then 0 times negative 5 times negative 10. So signs are different. So 0 is a neutral. Sorry about that. So it's 0 times negative 10, which is 0. There's no negative. Like I said before. Negative 10 times negative 20. Signs are the same, so it would be positive. And your answer is 200. Now, let's do our final example. It says solve. And you can use it on a separate sheet of paper. You can draw up the tic-tac-toe board. So, it says negative 4 divided by 2. Like I said, signs are different. Negative, signs the same, positive. So, negative 2. Then, 10 divided by 5 is, obviously, signs are the same, 2. Then, negative 40 divided by negative 20. Signs are the same. So, that's positive 2. Then, last, negative 15 divided by 5 equals negative 3. Well, that's it, guys. I hope you enjoyed the video. Special thanks to my friend Srini.
Hi.
For all of the technology and recording. So, we went over 6 topics. Expressions and variables, powers and exponents, orders of operations, comparing and ordering integers, adding and subtracting integers, and last, multiplying and dividing integers. I hope you enjoyed it. And my brother Rishi will kick us off with a drum roll. Like and subscribe.
Mr. Bo, teacher.
And Ms. DeBrasi, I hope you liked the video.